I'm here to give you a quick introduction to proteins, another one of our essential macronutrients. I love talking about protein because it's a nutrient that we both eat and create inside of our bodies. It would be impossible to talk about proteins without first jumping in and talking about amino acids, the building blocks of proteins. There are 20 amino acids that your body needs to create proteins. Of these 20 amino acids, our bodies can create about half of them. The rest have to come from our diet. Now that we know that amino acids make up proteins, what are some of these proteins doing? I'll start with collagen, which is the most abundant protein in all mammals and serves as the glue between our cells. Then we have the hormone and protein insulin, which is created in the pancreas and aids in the absorption and use of glucose in the body. Enzymes act on other substances to change them chemically and play a major role in metabolism. Hemoglobin are the globular protein molecules in blood that carry oxygen. As I mentioned, these are just a few examples of the many important proteins that keep our body running. Since we get about half of our amino acids from our diet, there's an important process that happens between when we eat something and when our body can begin to create proteins. That thing has a name, and it's denaturation. Denaturation is the irreversible change in a protein's folded shape brought about by heat, acids, bases, alcohol, salts of heavy metals, or other agents. When we eat protein, we need them to be denatured to liberate the amino acids. This process begins almost immediately, starting with an enzyme in our saliva, amylase, that will begin to break things down. Once the amino acids are released, they're absorbed and transported to cells and used to build proteins inside the body. Here you can see a normal protein structure and then what it would look like after it's been denatured. Here's a little fun fact about me. I'm actually allergic to a protein that's in a bunch of fruits when they're raw, but when I cook them or change them in any way, I'm able to eat them. So I can't eat a raw apple, but I can eat applesauce. And yes, it is a bummer to be a nutrition and not be able to eat raw fruit. An easy way to think about the denaturation process is thinking about a raw egg and what happens to it when you cook it. Albumin, the protein that's in egg whites, appears translucent when the egg is raw. When you use heat to cook the egg white becomes opaque and white. The change in the viscosity and color is an indication that the proteins have been denatured. Just in case you aren't sold on how important proteins are, here are a few other things that they are doing. They support growth and maintenance, they build enzymes, hormones, and other compounds, build antibodies, maintain fluid and electrolyte balance, maintain acid-base balance, and also have a part in blood clotting. Since this is a nutrition class after all, let's switch gears and talk a little bit more about the eating side of things. 15% of our daily need for energy comes from protein. Amino acids can be converted to glucose if needed. Assuming that you already watched the carbohydrate talk, you probably already know that carbohydrates are truly the best way to get energy and glucose into your system. If about 15% of our energy should come from protein, what happens when there is a lack of protein? In cases of severe protein loss from starvation, fasting, or other circumstances, protein is depleted first from the small proteins in blood, then the muscles, liver, and other organs. Also in cases of severe protein loss, we see things like marasmus and kwashiorkor, which Sarah touched on briefly in our first class. When we have too much protein in our diet, it cannot be stored on its own, so it's either going to meet immediate energy needs, make glucose to become glycogen, which is that storage form of glucose, or make fat for energy storage. Some of the health consequences of too much protein include heart disease, kidney disease, adult bone loss, and even some cancers. When it comes to eating protein, there actually are some forms of protein that are easier for our bodies to digest than others. This may not be good news for the vegetarians and vegans in the house, but animal protein truly is the easiest protein for our bodies to break down and use, followed by legumes and then grains and other plant foods. If you have a varied diet and you're eating a lot of different types of protein, you should have no trouble getting the amino acids you need. I mentioned before that you should aim for about 15% of your daily energy intake coming from protein. You can actually calculate what that would mean as far as weight goes if you take 0.8 gram for every kilogram of your body weight. And I'll show you an example of that calculation in just a minute. Also, the minimum you should be having in your diet every day is 10% of your total calories of protein, and the maximum is 35%. So here's a quick example of how you could find out how many grams of protein you should have based on your body weight. So this person weighs 150 pounds. We convert their weight into kilograms and then multiply that by 0.8. And in this case, the person would be able to have about 54.54 grams of protein each day. To give you an idea of what 54 grams of protein would be like, there's about 30 grams of protein in 3 ounces of beef, 22 grams in 3 ounces of salmon, 26 grams in 3 ounces of chicken, and 13 grams in 2 eggs. Or if you're not a meat eater, here's a nice little reference guide for how you can get your protein from other plant-based sources. Thanks for sticking with me, and hopefully you know a little bit more about the powers of protein.